At one or the other point of life, the question of your existence must have popped onto your mind. How can in this infinite web of cosmos we are the only known survivors? Are there any laws that govern this whole universe? Can we ever be able to decipher them? Okay, so if you ever thought about these questions, you are at a right path and I will be your companion for next few minutes. I will try to answer all your queries from the eye of breathtaking research humanity has done for centuries. Curiosity drives the humanity. From Greek and Latin philosophers to present day geniuses, the fundamental force that kept us inspiring was our urge to understand our surroundings. There were a lot of theories and inferences, but the journey of solid understanding began with Newton in 17th century. Remember that falling apple incident? I'm not sure about the credibility of the incident, but his groundbreaking research still stands tall in classical world. The simple formula you must remember from your high school. Yes, that is the successful depiction of the enormous force of gravity at classical levels. Moving forward in time, with greatest contributions from Faraday, Oersted, and Maxwell, we finally achieved what we call a unified theory of electricity and magnetism, the so-called electromagnetism. Yup, the force that drives almost every machine you own or work with. Remember those four famous equations of Maxwell? Yeah, that's all you need to create wonders and innovate until you lead humanity to unbelievable. Now let's discuss what actually we are trying to unite for so-called theory of everything. On a fundamental level, all the forces of nature can be categorized into four prominent groups: gravitational force, electromagnetic force, strong nuclear force, and weak nuclear force. Before leaping into the mysterious tales of unification, let's dig a bit into the fundamental forces and understand them. Beginning with the gravitational force. It is the force of attraction between any two masses anywhere in the universe. It has an infinite range and it holds almost everything that universe possesses. Talking about Maxwell's legacy, yep, the electromagnetic force, it is the force that governs all the electric and magnetic phenomena occurring in the universe. It has long range and it is even more stronger than the gravitational force. Here comes the third player: strong nuclear force. The force that binds nucleons, that is, protons and neutrons, together in atoms. It is stronger than the forces I mentioned, but it acts on nuclear scales only, that is 10 raised to power minus 15 meter. It holds quarks together, the present day fundamental particles that make up all of you. Here comes the finisher, the so called weak force, the power that can blow whole humanity. Yup, the force governing the radioactivity. It acts only inside the nucleus, so its range is even shorter than the strong nuclear force. Now let's come back to our destiny. That is a search for the theory of everything. The greatest mind of 20th century, or perhaps the whole history in 20th century, published three papers that brought a new leap in the world of science. Time, as we observe, was believed to be absolute, but Einstein proved that time is relative and gave a new picture of gravity. Einstein formulated gravity as an after effect of bending in the space time, where time is the fourth dimension added to three dimensions we already observed. Einstein, in his later years of life, was in search of the theory of everything. The wave particle duality was resolved, and now he dug into the world of quantas. Indeed, he was one of the pioneers of quantum mechanics, but he didn't like the idea of uncertainty. Remember the famous quote? God doesn't play dice. Yup, that was Einstein. A few years later, there came another revolutionary, the Werner Heisenberg, with his uncertainty principle. It states that the position and momentum of an object couldn't be deciphered simultaneously. The more precisely you measure one parameter, the more uncertain the other becomes. Here is the mathematical form. As h, the Planck's constant, is so small, so the uncertainty at the world we reside in is unnoticeable. But at atomic scales, it becomes so significant that we couldn't ignore it. This is an example for those interested in maths. That's gigantic. So we have to consider uncertainty in our calculations and accept the limitations of our understanding. Hey geniuses, don't lose hope. We have found a way in the form of quantum version of our classical theories. With these developments, there came a new era in physics, driven by maths. I will discuss all that in my upcoming videos. Until then, stay curious, stay mad, and keep deciphering. If this video added value to your life, hit that subscribe button and share this video. Thanks for watching.